Hello everyone, it's really great to be part of this great conference again. I'm Salih. I'm one of the Flutter and Dart GDs around the world. Right now I'm in Ankara, Turkey, and today I'm going to talk to you about the internal architecture of Flutter. Before we go through, let me tell you a bit about myself. As I said, I'm Salih. I've been doing Flutter apps over 4 years now. I've been a Flutter GD over 2 years now, so everything is going great. In my daily job, I'm working in Superlist and we are doing a desktop and mobile application by using Flutter. I hope I will be able to show you that in a couple of weeks, so stay tuned. And for now, let's continue with what we have for today. Today's agenda is actually going into 4 different steps. First step is we will talk about Flutter Sdk Architecture, how it is well designed in a way that it actually makes sense to us and it makes sense to use it in different platforms. Then we will talk about platform embedders and platform channels. This means that how do we communicate between the platform, the host that we are in, and how do we actually get the values out of it. Next step, we will talk about widget creation, what are widgets and how do we manipulate them. And lastly, we will talk about layouting, how do we do UI implementation, and how does the rendering works in Flutter. It seems like quite big topics, but don't worry, everything will be all right. And after today, I'm sure you will be learning a lot of things that you can actually use to explain how Flutter works to your peers or coworkers. So if you're ready, let's go with the first one, Flutter Sdk Architecture. If you simply Google about Flutter, you all already heard about it. It's not like 3-4 years ago that is a brand new technology. It is still young, this is for sure, but I'm sure a lot of people already heard about it. It is Flutter. Flutter is Google's UI toolkit that gives you a chance to have performant apps over web, desktop, and mobile. The good thing about Flutter is that it tries to enable you to have high performance app in a natural platform that you feel native. For doing it, they decided to use a heavily layered great architectural position in the SDK itself. SDK's main 3 layers are going like this. First one is framework. It is the top high level one, and as developers we will be working with that most of the time. The second part is engine part. Engine part is how the Flutter engine is working, how does the rendering happening, and so on. And last part is embedder part. The embedder part is the part that is handling the host related, platform related operations. We will go deep dive to these in 1 minute, but before we go on, I want to clarify something. This is valid for desktop and mobile, but for web, it's a bit different. We will not go deep dive into the web today. I will just show you the diagram and explain a couple of things now. As most of us are mobile developers, we will be going to this complicated diagram first. The web's diagram is quite simpler, as you can see. Flutter Engine itself has been written in C++. We will talk a bit more about this soon. But for web, it's a different story. Dart is a special language that can convert itself to JavaScript. And they wanted to use this power to have actually Flutter web implementation. This way, they wanted to have a Skia compiled Flutter version called Canvas Kit. The Canvas Kit is getting your Dart code, doing the necessary operations, and creates a web application out of what it has in a converted WebAssembly way. So this way you can have HTML, CSS, Canvas, SVG, and to be able to render to the WebGL, you are using Canvas Kit. Let's continue with the actual Flutter Sdk architecture, the embedder one. Embedder is the part that, as I said, it's the platform specific part. It gets the native plugins, it gets the app packaging. So if you want to have APKs or any other things, you will be using the embedder part. The embedder part is written with the platform specific languages. For example, if it's for Android, it is with Java and C++. If it's for iOS, it is using Objective-C and Objective-C++. And for Windows and Linux, it is using C++. So all the native operations that we need have been written with the languages that they belong into. So what does this embedder do? The first thing is it renders the surfaces, so it gives you an empty canvas in a way that you can draw, and it actually helps you to render the information into that canvas. The second part is the part that is about accessibility. All the accessibility tools that you have inside your platform, you will be getting this information back out of the embedder, so you can put this into action in Flutter. And all the inputs from user, like clicking on the screen or like right tap, double tap, whatever you can think of, is coming from here. And lastly, the message event loop. This means that all the communication happening between the platform itself and here, this is happening because of the implementation details that have happened here. And we will talk about that in a couple of slides. It's called platform channels and we will be using it. Using the embedder, Flutter code can be integrated into any existing application as a module, because the embedder part is already written with that platform. So if you want to add it to Android, you will just put in the embedder part and use it directly. So let's go one step up to the engine part. Right now we know about the embedder, we know about everything, but let's talk about the engine. The Flutter engine is a special point that actually is doing the heavy work for us. It is mostly written with C++. At the core of Flutter, the Flutter engine is working. It supports all the primitive and necessary things for Flutter applications. It is responsible for rasterizing composited scenes. It gives us a way to provide a low-level implementation of Flutter's core API, like graphics through Sdk. So Sdk is the graphics engine that has been developed by people, and it is actually using a high-level implementation of UI rendering. And this way of implementation, Flutter can have 60 frames per second. It also handles the text layout. You may or you may not know it, but text is really a hard topic in UI elements. You can see it in Android, you can see it on web, and it is the same for Flutter as well. And this heavyweight, it has been lifted off here. And file and network operations, the accessibility support that has been delivered from the embedder, and everything like plugin architectures and Dart runtime is happening here. So most of the heavy work that is making Flutter special is actually happening here. And the last point is about the top level, the framework, the part that we will be mostly working about. So the engine is exposed to the Flutter framework through Dart UI library. It is wrapping up the C++ code under Dart classes. This library exposes the lowest level primitives such as classes for driving input, graphics, and text rendering subsystems. So all the setup that has been down below has been delivered us by Dart UI library. Typically, developers interact with Flutter through this Flutter framework part. This provides us a modern and reactive framework that we are used to. It is using Dart language heavily, or like mostly or all the time, and it includes a rich set of platform layout and foundation libraries. So from bottom to the top, we have first the foundation part. Foundation offers commonly used abstractions over the underlying foundation. This means that all the foundation that we did for engine and embedder comes to the foundation part first. And it gives us the basic implementation of this, so we can get this out and use it inside our applications. Also, it has a block of services such as animation, painting, and gestures that we can see actually here on top of foundation. These are still low-level implementations. Next one is the widgets layer. The widget layer is a composition abstraction actually. It is helping us to have multiple UI blocks that we can use inside our applications. It provides us a corresponding class for each render object. We will talk about render objects in a second. Means that it provides us a class for how to rasterize, how to render UI elements over our implementations. It also allows us to define combination of classes that we can reuse. So we can create a button that we want and just play around with it. The Flutter framework gives us material and Cupertino libraries, and they are comprehensive sets of controls that we can use, that we can actually implement in our application to show material components and Cupertino, which is iOS specific components inside our application. Flutter has its own implementations of each UI control. So when we have a checkbox or a radio button, it is smart enough to understand to show the material one when it is Android and iOS one when it is iOS. So this was more or less about the Flutter Sdk architecture. As you can see, it goes to three folds, and you can understand that how it is implemented and how the embedder works, how the engine works, and how the foundation works, the framework works right now. The second point is directly combined to what we actually talked about now. The Flutter framework is relatively small itself, like the framework part is quite small, but many higher level features that developers might use is implemented in different aspects, such as packages or libraries that we say. For example, if you want to have camera or web view or whatever it is, like in-app payments and Apple authentication and so on, these are requiring some extra attention from the platform, and these are requiring the platform views and platform embedders. First of all, platform embedder is, I'm sure you are now, when you see embedder, you can think of what an embedder is. Platform embedder is the base platform that we have for our application. Instead of having multiple different implementation inside the library, it is using the power of the platform itself and connects itself to it. It provides an entry point. The platform embedder is created by, as I said, the Flutter people for the language that the host belongs to, and it provides us an entry point and initializes the Flutter Engine inside it, and it gives us a chance to reach out to the UI thread and how to raster and rastering thread, and it gives us a texture environment, app lifecycle, and many more information that we can have out of the platform itself. Because of these information, we can do thread management, input events, and window sizing, and many more. So we can use this information inside our application by simply calling some methods over framework level implementation. The embedders are specifically created for Android, iOS, Windows, macOS, and Linux, but you can also create your own embedders as well. Flutter team had worked on an Raspberry Pi implementation, and I'm sure you will love it if you check the blog post. If we talk about platform embedded for Android, it is using the activities that we know directly as the starting point, and all the views are controlled by a Flutter view. This is extended from the view class that Android has. And it renders the view that has been created by Flutter ecosystem, and it also controls the texture itself. For iOS, it is using either UI View Controller for iOS or NS View Controller for macOS. Inside each of the controller, it also creates a Flutter Engine and connects itself to the Dart virtual machine. And Flutter View Controller attaches this Flutter Engine into UIKit or Cocoa, so you can actually display frames rendered by Flutter Engine by using either Metal or OpenGL. And for Windows, it is simply working as a Win32 app. The content is rendered using an Angel, a library that translates OpenGL APIs calls to DirectX 11 equivalent, so simply Windows applications. and content is rendered using angles simply. So let's give it a break. Let's take a breath. A lot of information, a lot of embedded word, a lot of things to handle. Now you have the Flutter app open on your hand. You're looking at it and you're thinking, okay, I have the app here, but how does it communicate? Like, how do I just turn on the Bluetooth or like just show a permission? And how you do is platform channels. Platform channels are giving you a chance to create logical bridges between the platform that it belongs to and Dart and send primitive types throughout these bridges. This means that you can say key value pairs from one platform to another, and you don't have to give any tools. It's not going to be complicated. Dart part will be written with Dart, you can send the bridge on the other hand, and you will handle it with Kotlin or Swift or Objective-C or simply Java, whatever language you pick for the native platform. That is how we can actually use the libraries. We can actually create the packages that we use that is bringing us the file operations and many more. Lastly, I will talk about platform views. They are quite a bit frowned upon, so you don't have to use it. But if you want to have a real Android view or UI kit view, you can have it. It just lets you get the current view that you have from Android and copy it and show it to Android UI. So this is a bit expensive, or like iOS UI, it's a bit expensive, but it gets the gestures and it gets all the native input inside. And it is actually used back in the days by Google Maps package to provide Maps implementation in the early stages of Flutter. So we talked about a lot of deep dive stuff. That's why I wanted to give you a break here to talk about something simpler. On the surface, Flutter is a reactive pseudo-declarative UI framework. This means that developer provides a mapping of application state to the interface, and the interface is smart enough to change or show whatever it needs to show. It uses more or less the logic from React. So you can, if you're coming from web and have done React.js, there are probably a lot of things that are already similar to what you already know. So in most traditional UI frameworks, the user interface's initial state is described once and then separately updated by user code. And this is what we are going to learn. But first, let's talk about widgets. Widgets are immutable classes that are used to configure your UI. They are simply building blocks that you have, and you can put them together like a Lego and actually make something out of it. Flutter's motto is everything is a widget. This is a way to simplify things for beginners to actually make them understand how the composition, like how you can compose things together and make something out of it work. The widgets are used to manage a separate tree of objects for layout, which is then used to manage a separate tree of objects for compositing. Flutter is, at its core, a series of mechanisms for efficiently walking the modified parts of trees. This way, converting trees of objects into lower level trees of objects and propagating changes works really efficiently between these trees. And most importantly, we need to keep in mind that Flutter always uses composition over inheritance. That's why widgets are really lightweight and they can be expandable. But we talked about Flutter widgets being immutable, right? Why do we think that immutable widgets are something that is really important? So, state manipulation means that, or state management means that whatever you see on the screen, it can't be only static. It can't. We all know that apps are more complicated than that. For this purpose, in the base, Flutter team created two important widgets, stateless widget and stateful widget. Stateless widget is immutable, it doesn't do anything, it just shows what it has. Stateful widget, on the other hand, stateful widget class itself is immutable, but there's a state object inside it that keeps the information and it can be mutable. And mutability is happening with the thing that we are going to be learning about in 1 minute. But stateless and stateful widgets were good, but they wanted to give one more chance to actually create something new to pass down the widget in the widget tree, information in the widget tree. And that is when they came up with inherited widget. This means that the top information can be passed down to the bottom one by simple references in the widget tree itself. And this way the theme and everything is passed down in Flutter itself. As widget trees get deeper, passing state is hard, and this is their way of doing things simpler. But good thing to keep in mind is, one thing to keep in mind is state manipulation or inherited widget implementation, something that we rarely do. We use a lot of state management libraries like Provider, Block, and many more. And behind the scenes, you need to know that they are actually using stateful widgets and inherited widgets itself. So, last part, layout and rendering. We just said everything is a widget in Flutter, but this was a motto from the Flutter team. Flutter itself, it doesn't consist of all widgets altogether, because widget itself, all the operations that we're doing and every change can be expensive. We don't want this. So Flutter team decided to have 3 different trees: widget tree, element tree, and render objects tree. Widget tree, element tree, and render objects tree are the 3 different trees that we have actually that is doing the composition of the UIs that we have in the app. We talked about widgets. Those are the building blocks. They can be dismissible, but if they are dismissible, how can we make things more fluent and get rid of the immutability and show what we have? And this is where the element comes on. The idea is element is doing the heavy work for us. It is keeping the logical information of the UI. It is keeping the state object, so if it changes, it calls itself dirty and makes the proper implementation to make it clean. And it also keeps the parent and child information inside it. And render object. The render object is the one that is doing the communication between the engine itself and doing the UI painting. It just gets the information about sizes and colors and put them all to work together and actually show it on the screen. The render object gets the information from the top to bottom. The constraints comes from the top and the sizes go from bottom, and we can combine this information to show what we need on the screen on a scale that we want. The reason of separation of these 3 is, first of all, performance. I mean, you might be thinking, why don't we just combine them? But as we have the separation, the importance of the objects and the visibility of the widget itself gets more important. The clarity comes as a separation of concerns. You can see what element is doing, what render object doing, and what widget is doing here. So how does widget, element, and render object work together? You can see that first the UI interaction is happening. After the UI interaction happens, like someone clicking on the button, then setState is called. This is a function to recreate the page again. Then element itself is marking itself as a dirty, and the framework has a list of dirty elements. It says, okay, I will go through all of these and check out the dirty ones and make the proper changes to recreate themselves. But if it's clean, then I'm not going to create it. So this way, the heavy elements, heavy objects like element and render object, they are not recreated again. After it is going through unidirectionally down to elementary, it checks the created. If it needs to be recreated again, it's creating it again or marking it as clean. So let's put this into a simple example. This is the new Flutter sample application. It just changes the light theme to dark theme, and it gives you a skeleton application to move forward with. I put this into a tiny bit more complicated state. It just has the randomized IDs. This means that it changes the IDs in a random mathematical manner. And we will see how the change happens and how the recreation of the UI works. So this way you can better understand why the widgets are dismissible and why the render objects and elements doesn't change. So this is the first state. This is the before state. You can see it uses 54 as the first item, 10 as the second item, and 56 as the third item. And you can see that the render paragraph ID is 58EE8. So this object is render paragraph, which is a render object that is doing the drawing for paragraphs or text coming from rich text. And you can see that this ID is not going to change when I change the color and the text inside it, because it will be smart enough to understand that it can use the same elements and do the drawing simpler. So you can see that the sample item here is 35 instead of being 54, and the render paragraph ID is the same, 58EE8. This means that it didn't change. Let me go back and come back. It didn't change at all. It just did whatever it's supposed to show, but it uses the same elements, same information that we all needed. This way, we can definitely see that all the hard objects that are getting reused as long as possible, and Flutter is smart to decide on this quickly. So let's try to sum up. We learned that Flutter's slogan is everything is a widget. It revolves around building user interfaces by composing widgets that we have in the architecture. And as we use more basic widgets, we have more control over the system. And thanks to the aggressive composition that it has inside its architecture, the large number of widgets that require from us are carefully designed by the algorithms behind the scenes that is using really efficient calculations. And this way, Flutter is working really efficient behind the scenes, and this is how Flutter works in the deep dive. Thank you for listening. Have a great day. If you have any questions, I will try to answer them. And thank you very much.
ドロイド会議2021チャンネル登録をお願いいたします。